Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Alia binti Amiruddin and I will present about the introduction of the case. First of all, honey can be adulterated with cheaper sweeteners or indirectly by feeding the bees with sugar. One of the cases of adulteration honey found was from Berita Harian in November 2017. Reported that the majority of honey marketed in Malaysia, around 80%, is really fake honey rather than real honey. Next, in this case, there was a man who had consumed artificial honey for 6 years. Berita Harian state that 54-year-old Khairi Amri has been hospitalized for the past 3 months due to limited movement caused by the iron brace that was placed on his right leg and the incomplete healing of his toe. Khairil had been purchasing and consuming kelulut honey. He was confirmed to have diabetes in December 2016. Khairil does limit how much sweet food he eat and also avoid taking any of them. Next, according to an article published by Berita Harian, some dealers claim to offer pure honey based on the color of the product, the presence of tiny bubbles on the top layer, and the pop sound the bottle makes when you open it. Since they have been claimed that kelulut honey has a better nutritional value, customers have been more interested in buying it. Director Helpful of Mardi, which is Dr. Suri Ruwi, who found that 15 out of 270 samples of kelulut honey that were tasted are actually artificial honey that do not contain any of nutrients. Other than that, fake honey was made of sugar that contained in the syrup, but two main sugars present in honey are fructose and glucose. Sucrose in honey is 0.8 until 5%. The sweet taste of honey is attributed to its higher fructose content. I will present about the sample and chemical found in the adulteration honey. So the first sample and chemical found is inverted syrup. It has a cleavage of the sucrose into its monosaccharides, which is fructose and dextrose, and it has a unique light reflective properties. It also used in food industry for making artificial honey, and it has various quantities of inverted beet syrup were added to the pure honey. Next, for the maple syrup, it has a different color of syrup for different flavors. For the golden color, it has milk tasting syrup. For the amber color, it has a rich flavor. For the dark color, it has a robust flavor. And the last one, which is very dark color, it has the strongest maple syrup for flavor and sweetening. For canned syrup, it has a dark golden brown color. It also has a medium flavor intensity and has glucose and fructose. Canned syrup have two adulteration, which is direct and indirect. For direct, which is 10, 20, and 40% of syrup were added. And for the indirect method, bees were fed with syrup. For the corn syrup, it has two colors, which is light and dark. For the light color, it is colorless and has pure, sweet flavor. For the dark color of corn syrup, it is more toasty, caramel-like flavor, and has glucose, maltose, and higher oligosaccharide. For the last one, which is rice syrup, it is sticky, thick, and has a light brown or tan color. Rice syrup is less sweet than sugar and contains a slight caramel taste. It has three types of sugar, which is maltodextrose 52%, maltose 45%, and the last one is glucose 3%.
Hi, my name is Nusabina. I will continue this presentation by explaining sample preparation method. The objective of sample preparation method is to obtain a clean sample containing the target analyte before converting them into analytical instrument. Based on our cases, which is adulteration of honey, we found that honey is an organic sample. Hence, we use sample preparation method which is liquid extraction and also solid phase extraction. Alright, liquid extraction in the form of LLE is also known as a solvent extraction. LLE is a chemical separation technique that uses two immiscible liquid to extract one or more compound from a mixture. It is important to choose the correct solvent and to ensure that the extraction is performed correctly. Water, ethanol, and methanol are common solvent used for solvent extraction of honey adulterant. The first factor to be considered when choosing a solvent for LLE is based on polarity, which means that the solvent should be more polar than the honey. The next factor is volatile. The solvent should be volatile and easily evaporated. It will help to remove the solvent from the adulterant. And lastly, the solvent should be immiscible with honey to make sure that the two liquids are not mixed together. It will help to separate the adulterant from the honey. We will move on to the process in LLE. First, honey sample is mixed with the solvent in a separating funnel as shown as in the figure. The mixture was shaken and allowed to be separated. The solvent layer is collected. Meanwhile, the remaining residue is analyzed to determine the presence of the adulterant. Next are the advantages and disadvantages of using LLE. LLE is the method that a cheap and easy way. It provides a minimal operator training and is widely accepted in many standard methods. However, LLE require a large volume of high purity solvent and might be hazardous and harmful to the environment. LLE often form an emulsion and it is also time consuming. So now we will talk about solid phase extraction. Steps involved in SPE are conditioning, sample addition, washing, and elution. Choosing the best SPE stationary phase to use depends on the physical or chemical properties such as pH, pKa, and solubility of the analyte. There are two conditions in SPE, which are unwritten analyte while matrices are absorbed, but it is usually used for highly concentrated analyte. However, common use is analyte retained while matrix interference pass through, which mean remove. Three methods are available in SPE, which are normal phase, reverse phase, and ion exchange phase. The advantages of using SPE are SPE has a greater accuracy, less sample handling. There is no emulsion problem. SPE reduce harm and indirectly can improve safety because of reduced sample exposure. Meanwhile, the disadvantages of SPE are the operation is complicated and time consuming. It requires a lot of organic solvent, which resulting in high cost. Three common problems faced when doing SPE was poor recovery, reproducibility issues, and sample extract being insufficiently clean. From these two sample preparation method that we been discussed, we can conclude that SPE is the preferred method because of its high sensitivity and selectivity.
Now, I will explain about the sample analysis method. First is NMR spectroscopy. NMR spectroscopy analyzes the structure and composition molecule using atomic nuclei magnetic properties. It is useful for detecting honey adulteration and identify different types of honey. The NMR spectrum plot the intensity of radio wave emitted by honey molecule, indicating the concentration of each type. Adulterated honey's NMR spectrum can be compared to pure honey in, and indicating adulteration. NMR spectroscopy is sensitive, accurate, and versatile, making it valuable for food safety inspectors and honey producers. Honey analysis from NMR spectroscopy require less sample preparation and data collection times when compared with other analytical methods. Based on figure, the procedure that needs to be done to detect honey adulteration by using an NMR spectroscopy is that, first of all, a pure sample and adulterant was put in the machine, and then the NMR machine will do the process until the spectral fingerprint of pure and different type of adulteration honey is displayed. Through spectral analysis, we can indirectly identify and differentiate adulteration type.
Hi, I'm here to explain about sample analysis method for detect adulteration honey in HPLC. First, we must know the type of polarity analyte. In this case, analyte is sugar. Sugar syrup mostly are polar, So the mobile phase used in HPLC needs to be non-polar, while stationary phase needs to be polar. Polar samples are thus retained on the polar surface of the column, taking longer than less polar materials. HPLC works by separating the components of a sample based on their polarity and solubility in a mobile phase. For this analysis method, HPLC could detect both carbon 4 and carbon 3 starch syrup in honey samples, where 5% and 10% sugar syrups from carbon 3 and carbon 4 plants, respectively, added to unadulterated honey, were detected effectively. This effective solution for this analytical can be a combination of liquid chromatography (LC) with IRMS, known as LC-IRMS, to determine of the 13 carbon, 12 carbon isotope ratio of individual sugars derived from carbon 3 and carbon 4 plants for honey authentications. This HPLC IRMS does not involve temperature in its operation. In HPLC IRMS, temperature it is not directly related to detecting adulteration in honey. This is due to the column from HPLC was connected to LC RMS interface. From the figure HPLC, each honey sugar constituent is quantitatively separated by LC, converted to carbon dioxide in IRMS interface with the aid of a selective gas permeable membrane, and then carried towards the IRMS for the determination of the 13 carbon value using helium as a purge and carrier gas. LCIRMS approach targets to analyze many vital parameters of sugar like delta 13 carbon, value of every individual sugar, and fructose glucose area ratio in honey. This range helps to distinguish between authenticate and adulterate honey samples. In the figure graph of chromatograph, there are an area containing glucose, fructose, and sucrose. 13 carbon values were derived after measuring the relative concentration of stable isotope. The delta 13 carbon value of fructose was 24.27%, glucose 25.13%, and sucrose 26.67% for upper trace, whereas in lower trace, value of fructose was 23.59%, glucose 21.23%, and sucrose 12.54%. The optimum delta 13 carbon value of fructose, glucose, and disaccharides, mainly sucrose, in authenticate honey samples varies are from 23.2 to 27.5 for fructose, 22.7 to 27.2 for glucose, and 22.5 to 28.2 for sucrose. Adulteration indicates when the delta 13 carbon measurement exceeds or below the optimum range. So, in upper trace represents the chromatogram of authenticate honey, whereas the chromatogram of lower trace is for the adulterate samples.
Raman spectroscopy is a non-destructive, quick and valuable tool for detecting adulteration in honey. It works by shining a laser beam on a sample of honey and analyzing the scattered light. From the scattered light, it will produce Raman spectrum, which obtains fingerprint information about the molecular structure and functional group of samples. Raman spectroscopy is also suitable for the detections of honey samples because it is less susceptible to the interference of moisture in the samples during the measurement. Next, we analyze 100 pure honey samples and 100 adulterated samples which prepared by mixing pure honey with maltose syrup. As a result, we use the part between 500 and 2500 per cm for interpretation as only the spectral information is related to carbohydrate. In the region between 500 and 2500 per cm, peak were observed as shown in the table. The difference in characteristic peak
intensity mainly come from carbohydrates. The peak at 705 per cm is attributed to the C double bond O in the carbohydrate aldehyde group. The peak at 865, 915, and 1376 per cm are attributed to the CH of organic matter in honey. The peak at 950 per cm and 1373 per cm are attributed to the hydroxy group in carbohydrate, and the characteristic peaks at 1127 per cm are attributed to the CO bond in carbohydrate and glycosidic bond. The peak at 705 per cm is related to fructose, since fructose in pure honey generally account for about 50% of the sugar content, and the maltose is a disaccharide formed by the connections of two glucoses. Therefore, the concentration of fructose in adulterated honey is lower than that in pure honey. The increase in the intensity of other characteristic peaks may be related to the higher sugar content of maltose syrup than pure honey. Hence, the Raman spectroscopy is the one sample analysis that can be used to detect adulteration honey.
Each analysis method that we explain has its own characteristic, but the method has advantage and disadvantage as well. The feature for NMR is very high sensitivity, accuracy, and precision was high, while for HPLC it has medium sensitivity, high accuracy, and precision too. Raman has high sensitivity, medium for accuracy, and for precision. The advantage for NMR, which is highly sensitive, versatile, it can detect a variety of other trends, while for HPLC, it's accurate and also can identify other trends at very low level. And for Raman, it fast, easy to conduct, and also non-destructive. The disadvantage for NMR, it's very expensive and requires specialized equipment. For HPLCs, it's low, difficult to use with complex sample, and Raman cannot be used with complex sample, not as sensitive as NMR and HPLC. So the best method we choose is NMR spectroscopy.
In conclusion, honey adulteration is a serious problem that can have a negative impact on consumers' health and the honey industry. The adulterations of honey contains inverted syrup, cane syrup, maple syrup, rice syrups, or corn syrup. All the syrups contains sugar, which were maltose, glucose, sucrose, and others. There are two methods that can be used to extract the adulterants from honey, which were liquid-liquid extraction and solid phase extraction. LLE has a lot of disadvantages and has low sensitivity compared to SPE. Hence, SPE was chosen as the best sample preparation method. Adulteration honey can be analyzed using NMR spectroscopy, HPLC, or Raman spectroscopy. NMR spectroscopy can be analyzed for a variety of adulterants in honey. HPLC and Raman spectroscopy can detect a single variety of adulterants in the honey. Therefore, NMR spectroscopy is the best analysis because of its high accuracy and precision. Besides, the sensitivity of NMR spectroscopy is also more sensitive with their ability to detect adulterants at lowest concentration.